Elon Musk just confirmed what many inside the industry suspected, but no one expected it this soon. Starship Flight 12 isn't just the next test flight, it's the moment SpaceX brings out Starship version 3, a fully redesigned, next-generation vehicle built to rewrite the limits of reusable rocketry. Right now, behind closed doors at Starbase, engineers are preparing a mission that could force NASA, China, and every major space agency to rethink their timelines. A new Launchpad, a new flame trench system, upgraded Raptor 3 engines, a rebuilt heat shield, everything about Flight 12 signals a shift from testing to proving the future. And the stakes are enormous. If Flight 12 works, it becomes the foundation for orbital refueling, crewed deep space missions, and the aggressive push toward full two-stage reuse. If it fails, key milestones across the entire Starship program could slide months or years behind. This is the part of the story where the world usually sees the highlight reel. But today, we're going deeper. The real upgrades, the hidden strategy, and why SpaceX believes Flight 12 will mark a historic turning point in human spaceflight. Welcome back to Space Update 24H, your fast, clear, and no-nonsense source for everything SpaceX and beyond. Let's dive right in. Flight 12 marks the point where SpaceX stops thinking like a startup and starts operating like the company preparing the backbone of humanity's off-world future. And everything begins at a launch pad the world hasn't seen in action yet. Pad 2 at Starbase isn't just a new piece of concrete, it's a full reset of SpaceX's launch philosophy. Gone are the bulky steel legs and the shower-style deluge system that struggled under the raw power of earlier Raptors. Instead, engineers have built a box-structured orbital mount anchored above a dual-flame trench system, each trench carved to redirect the Raptor 3's blast with precision. The redesign isn't cosmetic, it's survival. With more thrust, higher chamber pressure, and tighter margins, Flight 12 needs a pad that can take punishment repeatedly without shutting operations down for months. Below the mount, the tank farm has been rebuilt from the inside out. Thicker cryo lines, higher flow rates, and a new cooling cycle that feeds the Raptor 3's enormous propellant demand. Water deluge jets now fire in synchronized phases, cooling each trench independently to protect the pad during the first 5 seconds of liftoff, the period engineers call the critical thermal window. It's the system Pad 1 never had, and one SpaceX must master if they want high-cadence Starship launches in 2026. But the ground upgrades are just the opening act. The real revolution sits on top of Booster 18 and Ship 39. The Raptor 3 engine is the headline change, not just because it pushes more than 9,000 tons of thrust at liftoff, but because it changes the economics of launch entirely. Musk has already explained the motivation: a simpler ignition system, fewer moving parts, and a cleaner plumbing layout. Raptor 3 isn't just stronger, it's built to be swapped, serviced, and mass-produced at a scale unmatched by any rocket engine in history. Engineers who have seen it up close describe the internal architecture as purposefully brutal. Thick walls where thermal shock matters, and aggressively slim components where flow efficiency offers more value. For Flight 12, every one of the 33 Raptor 3 engines will provide data on vibration behavior, ignition reliability, and burn stability. SpaceX is chasing a future where boosters can refly with minimal inspection. More like a jet engine and less like a museum artifact, Flight 12 is the first real test of that philosophy. Hot staging is also entering a new era. SpaceX has removed the standalone hot staging ring used in earlier flights and integrated the system directly into the upper structure of the booster. The new layout reduces mass, simplifies manufacturing, and allows the booster to separate with cleaner exhaust flow. Engineers expect the integrated ring to reduce stress fractures, one of the lingering weaknesses from the older design. If it works, this will become the baseline architecture for every operational Starship. The booster's descent profile is also evolving. Grid fins on version 3 are larger, thicker, and positioned to better leverage airflow during the high-drag portion of the fall. But there is a deeper purpose. These fins are early prototypes for future catch-compatible structures. SpaceX won't attempt a catch on Flight 12, but they're collecting aerodynamic data to map how the booster behaves under load when the chopsticks eventually grab it mid-air. It's a milestone required for true rapid reuse, and it starts with this mission. Meanwhile, Ship 39 carries its own list of critical upgrades. The payload deployment system has been strengthened and redesigned to reduce the risk of jamming, a problem that plagued earlier prototypes. And while SpaceX hasn't fully disclosed the flight's payload manifest, internal sources suggest the company will use Flight 12 to test a new deployment mechanism optimized for mid-orbit refueling tankers. But the defining upgrade, the one everyone from NASA to China is watching, is the heat shield. The version 3 heat shield is a complete overhaul, new tile geometry, a tighter bonding system, reinforced mounting points, better airflow control. SpaceX has spent months addressing the weak points exposed during previous re-entries, especially the aft flaps, which suffered the most violent heating in earlier missions. If the new shield holds, SpaceX moves a step closer to controlled, repeatable returns from orbit. If it doesn't, the timeline for operational flights stretches further into the future. Flight 12 also includes a Raptor 3 relight test in space. This is a make-or-break capability for orbital refueling, crewed missions, and future landings on the Moon or Mars. A clean restart confirms engine reliability under vacuum conditions, a challenge far greater than achieving thrust on the pad. Now here's where the pressure intensifies. SpaceX is racing the clock. To launch in early 2026, every major milestone, cryogenic tests, pressure trials, static fires, must run nearly back-to-back. The ship is still being stacked. The booster's entering final integration, and Pad 2 has never hosted a rocket before. The schedule is tight enough that even a minor issue could ripple across weeks of preparation. But SpaceX isn't operating blind. Behind the scenes, the company has been testing Raptor 3's ignition cycle on separate rigs, validating heat shield segments at extreme temperatures, and simulating hot staging separation under a range of pressure conditions. Even rumors inside Starbase suggest SpaceX is experimenting with a new real-time diagnostic system that monitors tile stress during ascent and descent, a system designed to catch weak points before they fail. All of this leads to one core truth. Flight 12 isn't just designed to succeed. It's designed to reveal the limits of Starship version 3 and then break them. Every component, every trench, every engine pulse, every tile has a purpose: to accelerate the path toward full two-stage reuse, orbital refueling, and sustained deep space operations. Flight 12 is the bridge between what Starship has been and what it must become. And once the engines ignite, SpaceX won't just be lifting a rocket off the pad, they'll be lifting the expectations of an entire industry. Flight 12 stands as the clearest signal yet that SpaceX isn't slowing down. It's accelerating every upgrade on version 3, from the Raptor 3's raw power to the rebuilt heat shield and the dual flame trenches, reinforces one message: Starship is moving toward real, repeatable, high-stakes missions. Not someday. Soon. And that's why this launch matters. It's not just a test of hardware. It's a test of the entire philosophy driving SpaceX forward. Rapid iteration, bold engineering, and the conviction that reusable heavy lift will reshape human spaceflight. Whether it's the new pad, the integrated hot staging system, or the future catch architecture being quietly prepared, Flight 12 will reveal how close we are to seeing Starship operate the way Musk has promised for years. If these systems hold together under pressure, SpaceX gains the momentum needed for orbital refueling, long-duration missions, and the first real steps toward a multi-planet future. If they don't, the data gathered here will shape every flight that follows. Either way, this mission pushes the frontier forward. If you found value in this breakdown, don't forget to like, share, and drop a comment about which upgrade you're most excited to see in action. And if you want more clear, fast, no-nonsense updates on SpaceX and the space race, subscribe to Space Update 24 hours and hit the notification bell so you never miss a new report. The next chapters are coming fast, and we'll be right here covering every step.